let's go to section 15.3, and it's going to be a double integral. In polar coordinate. Number one, polar coordinate. Okay, so for polar coordinate, right, you can turn any rectangular coordinate into a polar coordinate. So x, y. Let's say that you have a coordinate right here. X, y. You can get an angle right here. See, it is x and it is y. So you can get an angle theta. And then from here, you see that you got a right triangle. Right? The radius to be r. So x is gonna be r cosine theta, and y is gonna be r sine theta. Huh? Is it? X, y here is equal to r cosine theta or sine theta. Yeah. Okay. Well, a few more things that you get to know about this one is the r square is x square plus y square. We know tangent of the angle theta is y over x. Yeah. Here come 2 double integral. In polar coordinate, how do we compute dA? Okay, so here come x, y. I'm gonna take a piece of a circle here. A little bit bigger here. Okay, so that it has, of course, two angles. So this angle right here is alpha. The bigger angle is beta. Okay, so in here we're gonna have you got to cut this out into smaller pieces, and then I'm not gonna cut it out into too small enough so that I can put my writing on here. Let's say that you have this particular region here. So how do you find the area of this one? Well, this is the dA. This is dA right here. Huh? Sample area. This dA. Huh? dA. We just have to figure out how to compute dA here. There's going to be a change in the radius and a change in the arc length. Right? So this side right here, you see, is dr, small change in the radius, and then this one is the small change in the arc length. Anybody remember arc length? dr. So small change in radius is dr. What about a small change in the arc length? Is radius multiplied to a small change in the angle. Is radius multiplied to a small change in the angle. So this is the dA right here. Small change in the radius can be seen as either the length or the width of this very small sample area here. So it's length and width. A lot of people would refer to write dA as r drd theta. So now we have this one, and then from there we can do the setup, right? The double integral over the region D, fxy dA is integration from, and then another integral, right? In here is going to be a f, right? You got to convert xy into a r cosine theta or sine theta, and then the dA here is r dr d theta. We know the angle theta is from alpha to beta. It's the radius r. So now I'm gonna have to consider my region, right? So let's consider this to be my region D. So based on here, then the radius would be from some number A to some number B, right? Because we have a from here to here is all equal A, yeah. And then this one, oh my God, I'm running out of color. I'm just gonna have to bold this thing here and see. Or could be, so A to B. And what is so cool about this is that look at the limit of the integration. The limit is in constant. So it made the integral super simple to evaluate. Yeah, because I'm going to do a few more examples. So I'm going to give a negative 2 to 2 negative root of 4 minus x squared, root of 4 minus x squared, a minus x squared minus y squared minus x squared plus y squared dA. I'm going to simplify this a little bit, right? So minus 2 to 2 minus root of 4 minus x squared, root of 4 minus x squared, and then this is the 8 minus 2, right? X squared plus y squared dA. Yeah. Reason why I want to keep the x squared plus y squared is because of the substitution. You see, x squared plus y squared is r squared. We want that. Okay. Now we're gonna sketch out the region D and convert to polar coordinate. Okay, You got to sketch out the region D at the same time, right? Sketch D. Okay. Well, from here we see that based on here, right? You can tell that the dA here has to be dy dx. So from here you see that y is between negative root of 4 minus x square, root of 4 minus x square, and then x is between negative 2 and 2, right? So x, y. Negative root 4 minus x square. That's the good review here. It's this one. The bottom half of the circle. The top half is this one. Oh my god. Circle gonna look ugly, right? But it's just gonna give you some visual what is going on here. And then x go between negative 2 and 2, so negative 2 and 2, right? Circle like this there. It's the region D. Based on the region D here, in polar coordinate, well, we want to figure out where does the angle go from and where does the radius go from. A minus 2, right? X squared plus y squared is r squared. Dy dx is r dr d theta. Okay. Where does the angle theta go from? And where does the radius go from? This a disk, right? So the angles go from here. Let's say this is where the angle theta is. It go from 0 to 2 pi. And this is the solid. This, so the radius is gonna begin from here. It go to here. So R. Remember this a solid disk here. So radius go from 0 to 2. F r theta, right? Is gr h theta. Remember that theorem, right? Split this out 0 to 2 pi d theta, and then 0 to 2 a minus 2r square or dr. It's up to you. You can use the u sub or you can use anything here. It doesn't matter. Right? So there's just 2 pi right here. And this one is the, you know, I would prefer to distribute here instead of using the u sub. So it can be a r square over 2 minus 2 over 2 or 4 over 4, 0 to 2. Right? 2 pi, simplify this thing, 4r square minus half of r to the 4th, 0 to 2. So right. 2 pi 4 times 2 square minus the half time 2 to the 4th. 2 pi, and what do we have in here now? 16 minus 8, so that would be 8. 16 pi can be 0 to in order to sketch D, right, you're gonna know that y go from 0 to this curve here, 2x minus x squared, and then x go from 0 to 2. So y go to 0 is the x-axis. X is from 0 to 2, so it should be somewhere above the x-axis, but let's take a look at this thing here. Y go root of 2x minus x squared. So y squared is the, what do we have here? We have a 2x minus x squared, x squared minus 2x plus y squared. I'm gonna do a completely the square. Complete the square for this thing here. X squared minus 2x, and then well, I'm gonna do a plus 1. Gonna be a 0 plus 1, so it's gonna be a plus 1 here. Plus y squared. So what do we have here? We have a x minus 1 square plus y square equal 1. So it is a circle center at 1, 0 with radius 1. Right? Well, we only have half of the circle though, since y is equal to square root is the top half of the circle. So this is the top half. Yeah. And ta-da! Okay, I'm gonna move number 2 here. I should have a sketch out the circle before I put the number 2 on here. Okay, so this is the region D. Well, we want to convert it into our polar coordinates. We're going to find a way to describe this thing here. Now, we can describe this in terms of R and theta. What I know is that dA is R dr d theta. So that's what we know. Huh? We just want to figure out where does the radius go from and where does the angle theta go from. The angle theta is pretty clear. Everybody can see, right? This is the angle theta. So it does go from 0 to pi 2 because it is only in the first quadrant. However, the radius, right? This is the radius right here. It goes from here to the curve, right? You see, this is the radius. You see, it goes from 0 to the curve. Yeah, the radius go from 0 to the curve. So we got to figure out that curve, right? And because we did this thing up here, so I'm gonna just have to use this. We did this. So I'm gonna move it down here, and I'm gonna work it out a little bit here. Right? So it looks like we have a. I'm gonna move the x to the other side. So x squared plus y squared is 2x. I have a r squared is equal to 2. Well, x is r cosine theta. So we have r is 2 cosine theta. So 0 to 2 cosine theta. Oh, crazy, huh? This problem is crazy good. Got it. Now we're just going to set this thing up in polar coordinates. So convert to polar coordinate, and ta-da, we have a, well, it's all the theta, so the angle theta is from 0 to pi over 2. The radius is from 0 to 2 cosine theta, and then this is square root of r square d theta. 0 to pi over 2. Zero to 2 cosine theta, this r square d theta. Yeah, a little bit crazy on the trick here, but 0 to pi over 2, and this is going to be a 1 over 3 or 3, 0 to 2 cosine theta d theta. Sub it in and use a little trick identity. 1 over 3, 2 cosine theta to the power 3 d theta. Okay, so 2 to the power 3 is 8, so it's going to be 8 over 3. Cosine to the power 3 is going to be a cosine square times cosine. And then cosine square is the, I'm going to take out the 8 over 3 outside here. You can take it out. 1 minus sine square theta, cosine theta d theta. And then you got to use the u sub. Well, using the u sub, we have 8 over 3. What do we have? We have a derivative of 1 is u, so u sine, so it's going to be a sine theta. Derivative of u square is the u3 over 3, but then u sine, so it's going to be a sine 3 over 3. 0 pi over 2. Almost done. Oh, sine 0 is 0. How nice. Sine pi over 2 minus sine pi over 2 to the power 3 over 3. Okay. 8 over 3. Oh, what do we have? We have a 1 minus 1 to the power 3 over 3. So it's going to be a 8 over 3 times 2 over 3. 10 over 9. Yeah, and that is it.